Good day, viewers. I am creating these videos to support teachers of maths in helping learners make sense of mathematical concepts and their associated procedures and processes. And today what I want to look at is parallel line diagrams and the angles that we create within parallel line diagrams. And I'm going to use my geoboard here to sort of help me with that. So I'm going to start by creating two parallel lines. And of course, if learners were doing this for themselves, then they can create lots of different parallel lines, but probably only one at a time, or one pair at a time, on the grid. And then I'm going to create a transversal line. There we are. And of course, it doesn't matter what transversal line I create as long as it crosses both parallel lines. And then we can start looking at and talking about, where we can find angles that are the same. And the fact that we can find, some angles around here that are equal, some angles around here that are equal, but also some angles from here and here that are equal. And we can talk about why, where the transversal crosses this parallel line, we're creating some angles that are equal to when the transversal crosses this parallel line. And again, with the geoboards, we can create lots of different pairs of parallel lines or even groups of 3 or more parallel lines, and then transversals that will go across as many of those parallel lines as I like. And then from there, of course, what I'm going to move on to looking at is, okay, well, how do we make sense of what it means to be corresponding and what it means to be alternate within these diagrams? And so to help me with that, I'm just going to take a snip of this diagram. Here we are, because this is much easier done sort of visually and with the visual picture rather than directly onto the geoboard. But what I'm going to do here then is I'm going to say, okay, well, let's mark the angles around this picture between the parallel line, this parallel line and the transversals, and then let's mark the same angles around here. There they are. And so what I might do now is I might create numbers for each of these. I might start here with numbering 1 and then perhaps number them going around clockwise. And then, of course, in this circle, the important thing is I start with number 1 in the same position and I go the same way around. And so from here, what I can see is that, well, corresponding angles are angles from here and angles from here that share a number. So 1 in this top circle is corresponding to 1 in this bottom circle, 2 is corresponding to 2, and so on. But what I can also see is that the alternate angles are where you get a pair of odds or a pair of evens. So if I take an odd number from here, say 3, then the alternate angle will be the other odd number in the other circle. So 1 in here, and you can see 1 and 3 are alternate, and similarly 2 and 4 are alternate. And depending on how you exactly want to define alternate angles, you might say that it's got to be within the 2 parallel lines. So you might not say 4 here is alternate to 2 here, or you might say that it is. And then from a possible alternative is I might give these things labels, like I might label this the top left because it's on top of the parallel line and on top of the transversal, sorry, and to the left of the parallel line. I might say this is the top right because it's to the right of the parallel line and on top of the transversal. Similarly, I might call this bottom left and I might call this bottom right. Now, of course, the difficulty with these labels is it depends on the exact orientation of your parallel lines, whether the idea of top and bottom or left and right makes sense. But provided it does, this can also be a useful alternative to the numbering. And I can put the same labels on here. So I can have my top left here. I can have my top right here. because again, it's on top of the transversal and to the right of the parallel line. And again, I can have my bottom right here. I can have my bottom left here. And then I can say the similar sorts of things. I can say, that any angles in either circle with the same label are corresponding. So top lefts correspond to top lefts, top rights correspond to top rights, etc., etc., and so on. But I can see that the alternates have the exact opposite label. So bottom right, bottom changes to top, right changes to left, and there's the alternate angle, top left. And I can do other things with those, all with the numbers as well. So I can see that, angles within the same circle that have opposite labels are actually opposite angles, bottom, top, left, right. I can see that where one letter is the same, then those angles form a straight line. So top, left, top, right, they have one letter the same, top. Top right, bottom right, they have one letter the same, right. So those form straight lines. If you were doing that with numbers, and I'm sure you'd appreciate with numbers, that's any two consecutive numbers. So 1 and 2 will form a straight line, 2 and 3, 3 and 4, technically 4 and 1, which is perhaps where the labels just have a slight advantage, because 4 and 1 wouldn't be considered consecutive numbers, but we do have the same letter here. Okay, obviously they're consecutive. If you're only working with the digits 1, 2, 3, 4, you then circle back round to 1 again. So that's up to you. But this is just a couple of ways that we might perhaps help learners see what it means to be corresponding. Well, these are in corresponding positions. What it means to be alternate, and this is where I really sort of prefer this type of labeling, because there's not necessarily any reason why 1 and 3 would be alternate to each other in any sort of numerical sense. But if we're using labels like top, bottom, left, right, well, then we can see that this is the exact alternate label to that. It uses the other two letters that we might use. And so that's why these angles, and similarly these angles, are alternate. And we can start to make sense of that in terms of, like I say, in terms of opposite angles within a circle, and alternate angles having to include one angle from one circle and one angle from the other. So this is just sort of a quick video about how we might use, first of all, geoboards as a practical manipulative, and then transitioning into an image, a visual, to help learners make sense of the angles that arise from parallel line angle diagrams, and how we can sort of go on to classify those as corresponding and alternate, and also identify within them angles that might be vertically opposite or angles that might form straight lines. As always, I'd like to thank mathspot.com and its creator, Jonathan Hall, for the wonderful website that hosts all of these virtual manipulatives and so much more besides. If you've never been to mathspot.com, please do go and have a look on there. There is a wealth of things that are completely free that can be used to help you in your maths lessons. And if you are interested in manipulatives and visuals for supporting teaching of maths, then I would also recommend you visit my website, visiblemaths.co.uk, where amongst the many things you'll find on there, you will find a link to the publisher of my book, Visible Maths. The publisher is Crown House, and on their website, you can see some sample pages, and if it looks like the sort of thing that might help you in your practice or that you might be interested in, then you can, of course, place an order. I'll be creating these videos throughout lockdown and potentially even beyond. So if there is a particular video or a particular maths idea that you would like to see explored using manipulatives or visuals, then please do get in touch and I will do my best to create one for you. Thank you very much for your kind attention this evening.